Hello everyone, we will now discuss the next point about double sideband full carrier signal, which is its frequency spectrum. Frequency spectrum is nothing but the frequency domain representation of the signal which is represented in time domain. Frequency spectrum can be obtained by simply taking Fourier transform of the time domain signal. Now before this we have derived the expression of double sideband full carrier signal, that x of t is nothing but Vc cos 2 pi fct, where fc is the carrier frequency, Vc is the peak amplitude. We can also use the notation of AC or Vc, it's one and the same thing. I hope there is no confusion about that. The second and third term mvc by 2 into cos of 2 pi fc plus fmt plus mvc by 2 cos of 2 pi fc minus fmt. Now these were the three terms. Now ideally we should take its Fourier transform if I want to draw the frequency spectrum, but the time domain expression that we have in this case is very simple expression because it is already in the form of cosine functions, and we already know the frequency of each and every cosine function, and hence I can draw the frequency spectrum directly. So frequency spectrum is nothing but, as I said, the Fourier transform. I can call it capital X of f. It is plotted versus frequency f, and right now we are mainly interested in the magnitude spectrum part, which simply gives us each and every frequency value and its corresponding amplitude in the signal. You can see the very first frequency that is present is nothing but the carrier frequency with value fc, and its peak amplitude is vc. So the amplitude of this frequency is Vc. So sometimes frequency spectrum is also called amplitude spectrum. Apart from this, there are two side frequencies present, Fc plus Fm on the right hand side and Fc minus Fm on the left hand side. The amplitude of each of these frequencies is mvc by 2, where if you remember m is nothing but modulation index, which is defined as Vm by Vc, or you can also call it Am by Ac. And for double sideband full carrier, the modulation index m has to be less than 1. Now, if you remember why we call it double sideband full carrier, simply because you can see the original carrier is present as it is in the modulated signal. So we call it full carrier version of the modulated waveform. And because there are two sidebands present, we call it double sideband full carrier. Now, right now you can see that there are no sidebands, there are just two frequencies. Now why is this the case right now is simply because the modulating signal that we have considered, m of t, is single frequency modulating signal, Vm cos 2 pi fmt. It's a single frequency. In practice, any modulating signal will consist of frequencies. For example, if it is audio signal, it will consist of any frequency from 20 Hz to 20 kHz. If it's a speech signal, it may consist of frequencies from 300 Hz to 3.3 kHz approximately, and so on. And hence, there will not be only single FM, there will be multiple modulating frequencies, FM1, FM2, FM3, etc. And hence, there will be multiple frequencies on both the sides. So the upper sideband will consist of frequencies like FC plus FM1, FC plus FM2, FC plus FM3, and so on. And the lower sideband will consist of frequencies like FC minus FM1, FC minus FM2, FC minus FM3, and so on. And hence we will have a band of frequencies around the carrier frequency in any practical signal, and hence we call it upper sideband and lower sideband. So it becomes double sideband full carrier signal. Now, any frequency spectrum is always drawn as both-sided frequency spectrum. So please remember that, even though we are not showing it, but if I want, I can draw the frequency spectrum on the left-hand side also. Only then it becomes complete perfect representation. This is called two-sided representation. These frequencies will be negative frequencies, minus FC, minus FC, minus FM. And this will be minus Fc plus Fm. Now, when we show two-sided representation, in that case, I cannot keep the same amplitude on each frequency. So if I'm showing the two-sided representation, then I'll have to reduce the amplitude by 2. So this will become Vc by 2, this will become Vc by 2, and this will also become Vc by 2. And extra amplitude will be shown on the negative frequency side. So this will become Fc by 2, so that will become Fc by 4, and this will also become MVc by 4. Alright, so this is also MVc by 4. So if we have to draw two-sided frequency spectrum, then we have to show the amplitude which is half of the peak amplitude. So that's the complete frequency spectrum. You can draw it in one-sided form or in two-sided form, and as per you have to modify the amplitude values on each and every frequency impulse that we have.